Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me is Ed Charbeneau.
Thanks for having me again, Robert.
And we're going to talk about functional programming. But the interesting thing is we're going to do it all in C#.
Yes.
So functional programming is very interesting, very popular. A lot of people interested in it. Entire languages have been created for it, like F#. We've had F# episodes in this show. But it turns out, as you're going to demonstrate, there are a lot of things you can do in the functional realm in C#.
Right. So functional programming has been around pretty much as long as programming has. So why are we seeing this trend of everybody talking about functional programming now?
And remind us, what exactly is functional programming?
So functional programming is a style of programming where we're focusing on the inputs and outputs of functions in the application. We want to focus on mutability, which is writing data objects that cannot be changed. And we want to focus on this mathematical computation over keeping state in an application.
Why?
So for me, I feel like this helps with cleaner code that's more maintainable and less prone to bugs.
Okay.
But we've seen this upswing in functional programming because of a lot of distributed systems, multi-threading, and things where you don't want data to change while two different threads are trying to access the same piece of data.
Okay.
That's one of the reasons. We have cloud computing now with lots and lots of cores, and functional programming lends itself to better performance in that scenario.
Okay, cool.
Right, so again, we're going to focus on those inputs and outputs rather than building up classes that kind of have functions that change data in variables and keep track of a state.
Right.
That type of stuff is hard to maintain, and we have to build strict unit tests around it. And eventually, if you're changing enough data and mutating enough state, you're going to eventually miss something even with unit tests.
Okay.
So we're looking at separating that behavior. For example, like changing those states through functions, like void functions are very prone to this. If you're running a void function in C#, what is that function actually doing? Right? You're not returning something, so
Right.
it's operating on something, right? It has to be changing a variable, has to be changing the state of the system somehow. Otherwise, you wouldn't need to run it.
Right.
So we're going to focus on getting that type of stuff out of our code.
Okay, so we went back and forth over, we're going to do a lot of like before and after comparisons, and we went back and forth on whether or not to do these in Visual Studio or leave them in slides, and we decided that for the first few examples, we'll just do them in slides so you can easily see the way you would do it non-functionally, way you do it functionally. We'll make sure everybody has access to the slides and all of the code, but just wanted to let the viewing audience know why we're going to be in slides.
Yeah, we'll make this available for everybody. There's actually a self-guided workshop that I've written that's on
Okay.
GitHub. The slides are up there. We'll make sure we give out a link to that in the show notes.
All right.
But the reason for showing these in slides side by side like this is to have a little more impact. The demos in Visual Studio for these is mostly just writing out some values of the console. Not a lot of bang for your buck visually there. So we've just got some good comparisons here that we can look over. So if we look over this mutable side on this about mutable types.
And then one more thing, we talked about this a little before. Some of what you're going to show is new in C#7, and the rest of it has been in there for a while.
Yep.
So you'll call out things that are new in 7. If you don't call it out, then it's been in C# for a while. Right? So this isn't just doing it with C#7.
Right.
Okay.
And for just an example of the current thing that we're looking at, this is mostly a technique rather than a code feature.
Okay.
But there are some code features in it
Right.
that are newer, like not having to have backing fields, and just using the getter setter properties to create read-only properties.
Okay.
So there are a lot of new features involved in this, and we'll try to point out the ones that are brand spanking new.
Cool.
So let's talk about mutability real quick. I kind of gave a brief introduction to that already. We don't want the state of the application to change or a piece of data to change. Sometimes that's because of multi-threading. Like I said, you don't want two things trying to access a piece of data while it's mid-change. That could be very difficult to troubleshoot what's going on in a system like that. Or we may just have a reason that we don't want something to be changed once it's been created.
Okay.
So a technique to do that is we can create some read-only properties. So if we look at the immutable or the mutable object, the regular rectangle here, you can see we have a length and height property, and we can get and set those whenever we like. So we can change those at a whim. And then we have a grow function, and this grow function takes two integers and it expands the rectangle based on those two parameters.
Okay.
So if we were to new up one of these rectangles and set the length and height to it, and then call grow on that, in this example here, we'd add the values of 10 to it. We'd expand it by 10 on both of those variables. Now, in this demonstration here, this is being operated on one instance of the rectangle. So if we grow the rectangle, that instance of the rectangle gets bigger. Those values are mutated, they're changed, and now length and height have actually changed on that physical object.
Yeah.
So if we wanted something that's completely closed to being modified.
Which could be exactly what we want, right? There's
Could
nothing
be.
wrong with that.
No, absolutely not.
Right? You might have, the spec is that you have a rectangle and it can change in size, right? If there's more text going into it, it should grow.
Right.
Okay.
Yeah, there's no right or wrong way about these things. It's just showing different techniques that might fit a certain scenario better than another. So if we wanted to have the opposite functionality, we wanted to have something concrete that cannot be changed, what we can do is we can get the setters off the properties, take the setters off, those become read-only properties.
Right.
So we have to be able to set those somehow. So what we do is we move the setting of those to the constructor.
Okay.
So now we've also ensured that when we create a rectangle, it starts with a length and a height.
Right.
If we want to change those values, now we can't. So what can we do if we want to create a new rectangle based on the existing one that we have and do something similar to how we grew the other rectangle? So what we can actually do is return a new instance of a rectangle and add those length and height values through a grow function. So these are similar, yet the first example operates on the same instance. The second scenario, when we call grow, we get a brand new rectangle back that is now
So it's almost
modified
like a
in size.
clone, almost.
Yes.
It's cloning with the ability to change it in this example.
Yeah. So if we were to run this and we call grow on the immutable, and we compare the two, the first instance of the rectangle and the second one, they're not going to be the same instance. So that will be a false comparison. Where on the first one, if we set rectangle 1 and then grow it and set it to rectangle 2 and compare them, they'll be the same instance and they'll also be the same size.
Okay.
Okay. So that's one way we can handle immutability in C#. There's no built-in feature for it yet. People are asking for it, so we'll see if that one makes it into the spec.
All right.
And this was added with link. So we've got function delegates. Delegates have always been there, but they've been very heavy in overhead. When link was introduced to the language, we got func delegates, which are a lightweight version of doing function delegates in C#. These are very handy, and we see them used in link very often. We don't often see them in regular code day-to-day basis. We can do some really cool stuff with this, though. We can create a function that we can pass around like a variable. So in this example, we have add1, and we can say n plus 1. So we're just taking an input of 1 and returning the addition of 1 to it.
Okay.
Now, when we write that in our C# language, we say func int, comma int. So that means the first variable is going to be the input, and the very last is going to be the output. So we can have multiple of these as well. So the second example shows we have two inputs. We're inputting two integers, and the result is going to be one integer. Now we also have another example. They don't have to be integers. We have a func of int, so I have a parameter that's an integer, and the result is going to be a Boolean value.
Okay.
So I have something like add nums. The second line there, we have add nums. We take x and y. The result is the addition of those together. And then we have another one called is0. So this gives us a nice way to create self-documenting code, right? So we may have something in our code that says n equals 0, but in this way we write it, we can say is 0. So we're being very explicit,
Right.
creating very readable code. And this is kind of a dumbed down example. I don't think you'd be using a bunch of is zeros throughout your code, obviously, but it's, it kind of gets the concept going of how you can name a much more difficult function something that's very easily read.
Right.
So again, these would just simply output some things to the console. The last example, the last line there that says console write line, a count is 0, that's a nice little handy one there because we're using the link function count, and link usually wants something like the expression that's in the func itself, this n double equals 0, right? Is it 0? We can actually write count is 0 there and pass in the func delegate instead. So if we had something very complex like a blog post where it needs to be posted on a certain date and time, and we can name that function, is blog post published, something like that.
Right.
Okay.
Okay, cool.
So here's a big word that gets thrown around in functional programming a lot. Higher order functions. So what does that mean, right? Higher order functions, that sounds really complicated. It just means that you have a function that takes another function as a parameter, or returns another function as the result. So it's a very, very simple concept, just sounds very wordy, sounds very scary when you say it. We use these a lot day to day, at least I do, because I use a lot of link in my programming. Every link function is pretty much a higher order function. Almost every link function, where, count, all of those take a function in as a parameter. If you say where x is equal to whatever, that's taking in a function in that parameter. So they're all higher order functions, all of link.
Okay.
This is something that we can use very frequently through our code, but sometimes it's ignored just because people aren't in that functional mindset.
Okay, so walk us through this.
Sure. So one thing that people may not have ever done, and something that I like to do, is go see what's inside of the source code of link. Why not? Source code's all out there now. All the C# stuff is open source. This is the count function from link that I've got on the side here. And count actually iterates over this for each loop, and where it says if predicate element, so we're looping through this array, the element is the actual element in the array we're on, and it's running that function that's being passed into count every time it hits that line.
Okay.
So that's how that works. Evaluating things as expressions instead of statements. So the two code samples that you see here are identical. They do the same exact thing.
Right.
One is using a placeholder value. So we have a salutation, and we're going to say good morning or good afternoon based on the time of a 24-hour day.
Right.
So if we're less than 12 hours, we're still in the morning, greater than in the afternoon. So in the first example, we set an empty salutation, and then we check the hour, and if it's less than 12 o'clock, then we're going to set that salutation to good morning, and then it will return the salutation at the end. Okay? We can use a ternary operator to do the same exact thing and eliminate all the variables and the if statement.
The ternary is the one also known as the Elvis operator, right?
Right.
Yep.
So we have the same exact functionality here in both styles.
So how is this functional?
So we're focused here on the result of the operation, and we're not using any state mutation. We're mutating state in the first example. So we're creating a variable.
Yeah.
That variable is getting set to either one or the other and then returned.
Yeah.
And the second one, no variable at all. We haven't newed up any variable. So we have a complete single statement that does the same exact functionality.
Okay.
We'll show some more
So
in-depth examples that
Is the
hopefully
thinking that you could have two pieces of code running get salutation and changing salutation differently?
It's
I mean,
more, these are very basic examples
Right.
that if we blew them up to a larger scale application where we have multiple variables and we're setting multiple pieces of state and we're running different functions to change that state and then returning an output, that's where things get really dicey.
Okay.
This is a
Because I guess
very,
I never thought of that example as functional. I just thought, oh, cool, less typing.
these are more building blocks of
Right.
things that we'll show some integrated demos in a little bit here that,
Okay.
that maybe gives you that aha moment.
All right.
Right now, this might seem a little silly, like, okay, what's the big deal? We eliminated a variable. In a big application with lots of
Well, no-
variables, this might be different.
No, this was introduced in 6, I believe, C#
Okay.
6, the ability to do that. And it's better. It's way less typing. Instead of having the if-else, you've got this part here. Instead of having to return, you can just do the expression-bodied member. So it's one line of code to do 7 lines of code. And unless you get, if you get paid by the line of code, you think it's a bad idea. But other than that, it's much cleaner. But I never really thought of it as having anything to do with functional programming. I just thought it was a way of making it easier to code and giving me the ability to write less code.
Yeah, you'll see a lot of things I'm talking about weren't necessarily added to make C# a functional language, but to add exactly what you're saying, a better way to write code simpler
Yeah.
with less
But,
ceremony.
but this is following functional principles.
Yes,
Okay.
I'll show some
Interesting.
examples of how
All right.
it plays into the whole picture here.
Okay.
And hopefully some people have a good aha moment and like, wow, that's really
All right.
interesting way to look at it.
Cool.
We have to kind of lay that foundation
Yep.
first before we can get to the next level. In functional programming, we see a lot of pipelining. There's actually a pipe command and stuff like F#. We do not have a pipe command in C#. So we rely on kind of like this pseudo way of implementing it, and we do that with method chains. So here's an example of how method chaining helps control the flow of the values through the process. And the first example is we're doing a greeting. We're creating a string builder. We're calling append on it to add values to it instead of like concatenating a bunch of variables together. And then once we call toString, we can keep appending these or concatenating these functions onto the end of it. We can say trim the end, get that white space off, and then capitalize the whole thing.
Right.
We do that all in one swoop. There's, again, very little ceremony there. We could write that in many, many more lines of code. The next one, this is from a product of ours. I work with Telerik. We have the Kendo UI product. We have a lot of HTML helpers. So the result of this function is going to be an HTML grid. So we don't need to know all the stuff that it's abstracting, but we do want to have an easy way to build up this HTML grid. So we can call in Kendo grid, give it a model, name it, set columns on it, and then the result of that is going to be HTML.
Okay.
It's all done in one single pipeline. Those pipelines are often built using extension methods. So this is something that was introduced with LINQ.
Right.
Extension methods allow you to add a method onto an existing object and give it additional functionality from outside of the class. So again, LINQ, almost all, if not all, LINQ methods are extension methods. We use those all the time. And we can actually build our own extension methods. They're very handy. So we can add functionality to something like string builder.
Okay.
So in this example, we have a string builder, and maybe we want to be able to append things without if statements. So we can say string builder, we have to declare it static for it to be an extension method, and then we can say public static string builder append when.
Okay.
So append when something happens. And then the first parameter, you can see it starts with this. This identifies that it's an extension method of string builder.
Right.
So it will pass in SB is the value that it will pass in from the string builder that we're extending. And then we have this predicate value that is a true and false. So it says if the predicate is true, then append the value. So we're calling string builder.append. Otherwise, we're just going to return the string builder without modifying it.
Okay.
So you can see the usage might be something like this, where we want to build up an HTML button, and we're either going to append a disabled attribute onto it by passing in a true or false flag. So if we didn't have the append when, we would have to have string builder.append button, and then we'd have to break for an if statement, and then we'd have to go in and append again after that, and then call toString.
Got it.
So this way we're doing it one single flow as a pipeline. So again, we're building on those previous ideas that I was talking about.
Mm-hmm.
So we're going to dive into LINQ a little bit again. LINQ's a big part of all this. LINQ is probably the biggest piece of that functional programming. If you're already using LINQ, you're already doing some functional style programming in your application. Again, not a lot of people look at the source of those things. LINQ has some really cool stuff going on underneath. We can write our own LINQ type methods. We do that using the yield operator. And another thing yield operator does allows us to eliminate those placeholder values. So the first and second example here are identical pieces of code. The first one, we're looping through, we're creating a new list, and then we're adding elements to that list. We could do the same thing with the yield operator by yielding those out instead of building up a brand new list of integers and returning that list of integers.
Interesting.
So here we've eliminated that list equals new list event, and then we're not adding to that list anymore. We're just returning it with yield instead.
Oh, cool.
So this is where those things, again, starting to combine to make a bigger picture. This is a brand new, brand spanking new feature. This feature is so new currently, as we speak, it has to be added as a NuGet package. So you don't get this out of the box. You have to go to your NuGet package manager and do add system.value tuple.
I thought that wasn't true anymore with like one of the previews.
I am running preview 2, and I had to add
still
it.
have to? Okay.
So that may change by the final release.
Interesting.
Again, whenever this airs, that may be different. Currently, as my demo sits, it requires the package.
Okay.
So this is C# 7.1.
You know where it showed up? Framework 4.7 includes it by default.
All right.
That's what it is. So if you're using 4.6, which is the default in Visual Studio, if you're using prior to 4.7, you have to go get the NuGet package. Pretty sure this is true, but if you're targeting Framework 4.7, then it's built in. And that's why you had to go get the NuGet package, because it wasn't in the framework yet.
Okay. That may change with like .NET Standard 2, I would imagine.
Maybe, yeah.
So tuples, very...
Tuples or tuples?
If the way I understand it, it sounds like a couple.
Ah,
so if you have a couple of something,
all right,
then you have a tuple.
Got it.
So when you have a tuple, you can essentially return 2 values from a function with that tuple instead of creating a specialized class that just has 2 members on it.
Yep.
So this is very easily written now. We can just say double lat, double longe. Now, the thing that's important to note here is we don't have to name those. When we consume it, it will be item 1, item 2 if they're unnamed.
Yep.
So in this instance, I named them.
Names if you want. Right.
I named them to make it easier on the next developer that comes up to use it. And we can say get coordinates, and we could pass it a query string. You know, maybe we're on Bing Maps, and this is how it functions behind the scenes, right?
Okay.
We can do a search query and return the latitude and longitude, and then you might recognize that address.
That's probably where we're at right now,
That's where we're standing right now. So if we
I
pass
only
in,
know it is building 25. I don't know any of the addresses around here.
So if we were to pass in this address, we'd get the latitude, longitude points of where we're standing.
Okay.
Okay. And then we'd access those through the return value dot latitude dot longitude. Yep. The compiler understands, Visual Studio understands, and we get IntelliSense and all that good stuff. So we'll just talk about this for one brief second. The next set of demos I'm going to show are in code.
Okay.
The piece of code that I'm talking about is code kata. Okay. So a kata is like a code practice. It's we're writing practice code just to either demonstrate ability or learn something new. And in this case, I wrote it to learn more about these functional type of pieces to the language, and I put it all in a workshop.
Okay.
Now the workshop is based on scoring a hand of poker. So you have concepts where you're taking a list of cards, so you have a value in a suit, and you're trying to either see if there's pairs or three of a kind, or you have a straight, which is consecutive numbers, things like that. It's actually a really good kata to do because you run into a lot of scenarios that mimic things that you might have to perform in real life. And it's just those types of sorting capabilities and counting and things that you run into, like business rules.
Right.
It actually mimics those very well. So I like to do the card scoring, poker scoring algorithms.
Okay.
It's fun. At least it's fun for me. I enjoy it. And like I said, those business rules seem pretty similar when you get to like real life scenarios.
Right.
You have those moments where you're like, oh yeah, that's just like the time I had to, find three of a kind in a. And another good thing is you can be visual with it. You can get a deck of cards out, you can throw them on the table, and you can move them around.
Right.
And pretend in your head how those algorithms are working. Sometimes, if you're newer to development, that visualization gets you over the hump, over that learning curve.
Okay.
So let's use all those things we talked about in a bigger scenario,
right,
and we'll again build kind of at a small base and work our way up. So this is like a 4-hour workshop, and we're condensing it down very, very quickly.
Okay.
So we're starting kind of at the end. The first thing we're going to do
that in 4 toolbox episodes.
The first thing we're going to do is find the high card of a hand. So we have a 5-card hand of poker. We have 5 cards in an array, enumerable of cards. It has a value and a suit. So one way to do that would be to create a high card variable and just take the first card out of the hand and say, this is the high card. Then we'll loop through with a for each and go, okay, is the next card bigger than the one that's the high card? If it is, swap them. And we'll keep doing that until we get the highest card. We'll return that. There's a billion ways to do this, really. We could use a sort algorithm. Very inefficient for this, but it will work. Another way to do it would be min-max, but with more than a single variable with an object like this, you have to create a comparer, custom comparer for it.
What are you maxing?
Right. So
I guess it's the value in this case. Right?
Yeah. If we want to return that physical card object, though, we have to have a specialized comparator for it. Anyway, there's a bunch of ways to do it. This is probably one of the easiest. There's actually an easier way. Okay. So I've got this. People don't want to see me type code. It's horrible. So I've got some spoilers here, and we'll work through this this refactoring. So the first thing I want to do is remind you of that ternary operator. So we could actually eliminate this guy here, and we could say, take the high card. If the next card's greater than, then go ahead and assign that. Okay, we could do that. Or we could just use a link function that does all this already. So there's one right out of the box, so we don't have to implement anything new. We actually could back this up here and say we can use this aggregate function instead. So let's copy and paste this guy in, and we can see kind of how the aggregate works the same way. So I'm going to paste this in. It's going to error out because it's not, I want to keep them there for comparison.
Okay.
In our algorithm that we're using here, we're taking a card and we're setting that card to the first value. That's actually what the aggregate method does as well. So it's gonna create that variable, and then it's a higher order function. So it takes a function as a parameter, and that parameter is the method of comparing that element that's being held in memory to the next element in the array. And then what we can do is say the same thing that we're saying here. If it's greater than, then give us the next card. If it's not, then give us back the high card that's already there.
Okay.
So we can take all of this code and delete it. And we could say return cards, aggregate, the high card versus the next card, and if one is greater than the other, then give us the result.
Wow.
Okay, so since we only have one line of code, we might as well use an expression body
Yep.
member. We can take that guy, and we can remove the return statement, and we can remove this closing curly brace.
Yep.
There we go.
Cool.
So we just eliminated 6 lines of code,
Mm-hmm.
replaced it with a single statement. So that's
And you're not creating variables for the sole purpose of changing them so you can get an answer back.
exactly.
Right.
And that also reduces the ability to create a mistake,
Yep.
name something wrong, have the operator the wrong, on the wrong variable, something like that. So very, very easy and very readable. We have high card, next card. And we can walk through this very easily. If there's ever something that consumes this, we need to go back and look at the code. It's very easy. It's very named, very well named. So we know this gives us the high card. Next example. In a poker game, you have to look and see if you have pairs in your hand, or 3 of a kind, 4 of a kind.
Right.
That's an interesting thing to figure out in C#. There's, again, a million ways to do it. You could create lots of variables, track things in state. Since we were on the subject of concurrency, I thought it'd be fun to use something that deals with concurrency. So we're talking about multi-threading and the reason for functional programming. And there's a little bit of an element of functional in here because there's a higher order function at play. So I'm actually going to go over here and open up a visual for this if I have it still. I don't have that visual with me anymore.
Okay.
But essentially, what we're doing here is, unlike a regular dictionary, when we add a value to it, concurrent dictionary checks to see if the value is already there. And if it is, it lets us run a function.
Oh.
So what we can do with a hand of cards is I can walk through the hand and say, the first value is a 2. Okay, I have a 2. If the next value is a 2, run a function and increment a counter.
Okay.
So I can say, okay, I have a pair there, so I get a tick of 1, of 2. I will add 1 to a 1 and get a 2, and so on. And it'll count the number of a kind in that hand.
Okay.
So this is a function that you don't get on a regular dictionary. So like I said, we go through each card and we can say add or update. This is a built-in function of the concurrent dictionary. We'll pass in the value as the key, and then if it's not there, the value will be 1. If it is there, then we'll just increment that 1 to 2.
Okay.
So this gives us an easy way to count these values. Now, I talked a little bit in those slides about creating extension methods and doing pipelines. So if we wanted to abstract this away so we could have a simpler algorithm to read, we can create an extension method. So I've already got it created in here. Basically, we're copying that same piece of code. So this is our concurrent dictionary that's being created. And we're going to be able to name this something to give the next developer an insight to what's going on and kind of make self-documenting code. So I can call this to alike. So we're going to have cards. We're going to change those cards to things that are alike. So it's going to return a dictionary of items and the number of items in that dictionary. So with that extension method, I can come in and erase all this code, and I can say to alike in here. Oops, I have the dictionary still. I can say cards to alike. And then once they're alike, I can just say, are there any items in that array that are equal to the number I'm passing in? So I want to say has number of a kind. I pass in the number of a kind I'm looking for. Am I looking for 3 of a kind? Pass in 3. It changes them to alike values and then checks, are any of those numbers 3?
Cool.
So now we have, again, it's a single statement. We don't need this. We can take that away. We can create a expression-bodied member. We have the same function. The next one, I won't go through the whole process of refactoring, so I want to focus on what actually it's doing here. The next one is has a straight. So we're talking about things that are in order.
Yep.
We want 4, 5, 6, 7, 8, that type of thing. This can be a little bit difficult to solve. There's again many ways to approach it. We can take that array and see what the min and max are, and then calculate the distance between the min and max. As long as they're sorted, it will give us whether they're in consecutive order or not. Yep. We can also create our own link method. So there's a link method called zip that works on 2 arrays at a time. We can actually use that with a combination of some other code that makes it work, or we can just create something very custom that we can use in other applications if we need to. So I've created this extension method called select consecutive. So what it's doing is, unlike the normal select method, where you look at the sequence of an array item by item, it takes the first item and the second item and looks at them at the same time. Then we can add a parameter, so it's a higher order function. We'll pass in a function that decides how to compare those 2 values together. So we're selecting 2 things at once. So select consecutive is what I call it. It takes in an IEnumerable. Again, this is generic, so it's not just for cards. I could use it on any type of value. And it takes the source twice and gives us a result. So the same source takes the same list 2 times, and we return the resulting value from it. So we're going to loop through, and we're going to knock off the end because we're going to walk through. We don't want to go step over the end. So when we say we're at this position and next, we don't want next to fall off the end of the stack.
Yep.
And then when we return this, we do our yield return. We're going to pass. We're going to operate on our current index, and then the index plus 1. So this selector is our function that we're passing in, and that can do anything on these 2 values that we want. So if we go back to our code here, we do select consecutive, current and next, and if the value plus 1 is equal to the next value, which means it's 1 greater,
right,
then we're just comparing those 2 to see if they're equal. And then we can just check that returned array to see if all of those values are true. So if this value plus 1 and the next value are the same, that's true. Yeah. True, true, then they're all just 1 greater than each other.
Wow.
So we can select consecutive. And we could change up this this function that we're passing in to other things in other applications and do different things with it. So that expands the usefulness of it greatly. So got one more kind of big, hopefully this is the aha moment for folks here. This is a really cool one. I like this one a lot. What we're doing is we're going to get the score of the hand. Okay. So we've built all these functions that give us things like, is it a royal flush, is it a flush? And you can see all these down here, 3 of a kind, 4 of a kind, full house. Some of these are just comparing 2 things together, like a full house, for example, is a pair and 3 of a kind. So we can just use these 2 functions together. If they're both true, then we have a full house. So we have the stack of all of these rules, and we could go through that imperative process and set up a variable and say this is the hand value, and then walk through each of these and set it manually, return that hand value. It's very inefficient. We're walking through every function. We may not need to run them all to find the hand's actual score. We could also do what's called a return early. So we could run these functions in sequence and just return the value immediately. So we could say, if it's a royal flush, go ahead and return that it's a royal flush.
Yep.
So immediately the function returns and it won't get to the next line. That's one way we could do it. Here's another way we could do it. We could use that ternary operator. And we could just chain the living heck out of it.
Chained tenaries.
And
Cool.
we can just go through these until it evaluates to one of them,
Yep.
and then we have our value. However, there's an even better way to do this. And this is the one I really like. So remember that tuple that we talked about?
Mm-hmm.
What if we used a tuple here instead? Let me comment this guy out. We don't need him anymore. And what if we took all of our functions that we're running and put them in a tuple? So we have a tuple that is a func. Remember we talked about function delegates earlier? That takes a list of cards and returns a Boolean value. We have a lot of those.
Right.
Every one of these takes a list of cards and
Yep.
returns a Boolean value. Every single one. And then we can just pair it up with the hand rank. So we know that a royal flush results in this royal flush value. So we're going to pair those with a tuple. And we can put those in a list.
Okay.
So now we have a function that's a value in a list, right? This is really something that I think is neat that we can do with it. So now we can use link on it because it's in a list. So I can say get score, and then my rankings is this right here. This is my rankings. So I'm going to return my rankings. And the first one, first is a link operator. It says, give me the first one, and we'll call the eval, which is essentially the method that we passed in as a delegate.
Okay.
And if it returns true, then we'll give you that tuple. So what this allows us to do is not only we're going to short circuit operate this. So what I mean by that is we're going to look at this list of functions and I'm going to go through them. The first one to return true is the only one is where I'm going to stop. I'm not
Okay.
going to run the rest of them. That's a waste of process.
Right.
So we will immediately return that first one. We don't have to loop through every single one of them. And then once we do, we'll just grab the rank off of it.
Cool.
So what's even cooler about this is now the order doesn't even matter.
Right.
Because what I can do is come in here and say sort or order by, and I can pass in the card and sort them by rank. So now they don't need to even be in order when I get them. So that
Right.
means I can pull them in from somewhere else. I can pull in house rules from somewhere. They could be a part of another package or through dependency injection. And it doesn't matter which order they're in when they get injected into the list, as long as they're sorted by the rank is all I care about. So that's much more
crazy.
flexible than this returning over
Yeah.
and over or setting up a variable and walking through all those things. It's not wasting all that process.
Right.
It's grabbing the first one that executes to true.
Wild. That's some
So
crazy
hopefully
stuff.
all those things I
Yeah.
talked about kind of came together and made sense. I know the tenaries were up there, kind of why does that matter? But as you can see, they start combining together into something bigger.
Yeah, so we'll have this source code available. People can go through it at their leisure and kind of get a sense of, I mean, there's some learning involved to be able to get to this point.
Yes.
But this is all stuff that's in C#, and I learned a couple things that I didn't know were in there, so that's kind of cool.
Good. Yeah. There's a lot of new stuff that's
Yeah.
being added all the time. The pace of those additions has really picked up.
Yep.
And like things like tuples, as you can see, really
Yeah.
changed it. I could do this before, and actually in the workshop that is published on GitHub as of today, which I'll be updating,
Okay.
does use a special class to do that. But with the addition of tuples, I was able to remove
Right.
an entire class out of the code sample.
All right, cool. All right, thanks. There's some
Absolutely.
cool
You're welcome.
stuff in there. Great primer on functional programming in general, and then a great look at some of the features of C# that we may or may not have known were in there.
Yeah, I like to do all these things, refactoring,
Yeah.
to make this a little bit more brief. I don't show all the unit testing that's going on. All these things are tested, and as you write them, you can use the Visual Studio real-time unit testing if you're using the Enterprise Edition. And so you can write these things out and refactor them and watch it being unit tested as you go. Very cool stuff.
All right, cool. So download the code, play around with it. Thanks for coming on.
Thank you, Robert.
All right, we'll see you next time on Visual Studio Toolbox.